Let's start with our first forecasting techniques, moving averages. This is an intrinsic forecasting technique based on historical data. So we have the sales data or the demand data for the last 12 months from January to December. And now we want to know what will be the demand for the next January. Well, if we have a look at the numbers, the demand seems to be always between 70 and 90. There's a very low demand in March and in October with 66 and 63, but yeah, it should be some, or the demand is often between 70 and 80. And now, how to forecast the demand for the next January? Well, we could just use some rules of thumb. For example, the first rule of thumb that can be useful, and I want to show it to you as an example, is the demand for January of the next year will be the same as the demand in the December of this year. So in that case, we would say the demand will be 84. So we just say nothing will change to the current months. And for some situations, this type of forecast is not bad. For example, when you do a weather forecast, you're not so bad if you just say the weather tomorrow will be the same as today. Of course, it will not work for all situations. Another rule of thumb is we just take the January demand for next year. We take it as the same as the January demand from the current year. So in that case, we would say the demand according to rule 2 would be 92. The more random fluctuations in the data exist, the more limited the use of these simple rules is. And in general, it is very good if you try to forecast the average demands of a month. So when you have some demand or sales figures for January, for spring, for a year, that you try to create an idea what will be the average demand in a typical January and try to forecast this one. And our first technique, our first method for forecasting is called moving averages. We calculate the average demand for some periods of the past, and we use that figure to forecast the next period. So for example, we calculate the average demand of the last 6 months, and this average will be the forecast for the next months. How does it work? At the end of the next period, we drop the oldest period demand and add the youngest period demand and recalculate the average. That means we move by one period forward. Let's use the data from the previous slide, this data, and calculate the 3 months moving average. So if we want to calculate the forecast for the next January, we take the data of the 3 previous months, which are the demand of October, the demand of November, and the demand of December. The average, to get the average, we divide by 3, because we consider 3 months. And let's go back to the previous slides. You see the demand for October 63, then 91, then 84. We add this up, divide by 3, and according to this 3 months moving average, the forecast for January will be 79. Now, how does the name moving come from? If we want to calculate now the forecast for February instead of January, we move the calculation by 1 month. That means we drop the demand for October, which was 63, and we include the actual demand of January. So we don't include the forecasted demand, which was 79, but we include the actual demand that we could observe. In this example, this demand was 90. This is just a number I made up. You cannot know this. You need to observe this number. And then the forecast for February includes the demand, the actual demand of November, December and January. And again we calculate the average over these 3 months, and the forecast then would be 88 units. And if you apply moving averages, something like a 3-month moving average is common, but of course you can use any number of months or years that you think are appropriate. Let's have a look at one example about the moving average. So we are given the actual demand for 10 months in the table, and the first job is to create a graph for this demand. I will show you the solution on the next slide. However, it is really a good practice if you just do a quick drawing yourself and then check your results. What I also would like you to do is try to prepare a guess for the demand of month 11. You see there is some kind of pattern in the demand. Months 1, 4, 6, 7, it's somehow always high demand followed by a low demand, and we can try to use this to include it in our forecast. And now exercise the question number 3 is we want to calculate a 3 months moving average for the months 4, 5, 6 and so on until we have a forecast for month 11. With this data we cannot do a forecast for the months 1, 2 and 3 because we need 3 months data to calculate the moving average. So how to calculate the 3 months moving average for month 4? We just take the 102, the demand 102 from the first month, plus 91 for the second month, plus 95 for the third month, which is 288. We take the average by dividing by 3, and then the forecast for month 4 would be 96. This is the 3 months moving average for month number 4. And you repeat this for the other months, and you always take the actual demand. You do not take the forecast calculated. You calculate the moving average by taking the actually observed demand. And now when we include all these results, they are on the bottom of the slide and included in our drawing, you see that this demand, the actual demand, has some kind of sawtooth pattern. It's going up and down, and there's a slight trend. There seems to be a slight trend that the demand overall is increasing, and you can see that the forecast, which is drawn in red, also reflects this and is going slightly up, and this average demand that we forecasted is much more stable. And you also see it's somehow between the high demand and the low demand, so it seems to be a useful approximation to this situation. If the trend in the data is stronger, then the moving average typically lacks this trend. So if there's a lot of trend, the moving average can be not such a great option to calculate the forecast. And in general, the more periods we include in calculating the moving average, the slower the moving average adjusts to this trend, the greater the lag is. On the other hand, the fewer periods we include, for example, if we take a 2 months moving average compared to a 5 months moving average, then the reaction is much quicker, but of course the outcome is less. It reacts quicker to all kinds of changes. And here I have a constructed example for you with the two tables. You see on the left side in the table the demand in each period increases by 1000, from 1000 to 5000 in month 5. And in the right table I have exactly the same demand data, but there's not a clear trend, but they are just placed randomly. But there are also the 5 demands: 1000, 2000, 3000, 4000, 5000. Though the average demand of both tables is the same. If we calculate the average over these 5 periods, then this is the same. But the sequence of the numbers is different. Now if you calculate a 5 months moving average for this data, the result for both tables will be the same. What is the 5 months moving average? It's 15,000 divided by 6. Divided by 5, and the average demand is exactly 3,000 units for both tables. So the 5 months moving average would create the same outcome. However, the 2 months moving average for the left table would forecast 4,500 units, while the 2 months moving average for the right table would forecast 2,500 units, much lower forecast. So you see that the fewer periods you include in the moving average, the quicker it reacts. And so the moving average, to sum this discussion up, is well suited if the demand is quite stable and there's only a little trend or seasonality. In these situations you should use a moving average. And it is also good to filter out some random fluctuations. However, if there's a lot of seasonality or trend, then rethink your choice for the moving average. There might be a better method out there.